Hello student, today's lecture we study again the laws of logarithm with example. First law of logarithm, log m raised to n is equal to n log of m. Log m plus log n is equal to log m into n. If log m is equal to log of n, then m is equal to n. We have to revise these laws of logarithm once again because next example totally based on these laws of logarithm, law of indices and laws of exponent. Let us start from the next example. Here in this example, log x plus 3 to the base 5 is equal to 1 minus log to the base of 5 x minus 1 is there. Here suppose minus sign is there, so we can shift this term in the left hand side of the equation and 1 remain as the same. We observe that both the logarithm terms have the base 5. That's why log x plus 3 into x minus 1 because of log m plus log n is log m into n is equal to 1 remain as the same. Here we convert logarithmic form in an exponential form, that is a raised to x equal to y. That means log of y to the base a is equal to x. Means base we have to write here. Answer 1 goes to index and this term remain as the same. Now next step, x square plus 2x minus 3. We get the bracket expansion. X into x, x square plus 3x. Next, obviously, next one we have to take the minus x and here 3 ones are 3. Here plus 3x and minus x gives the 2x substitution. We expand the brackets of the plus and minus symbol. Here main thing is important. Here one we have to have the 5 raised to 1 derived from the logarithmic convert into exponential form. Now let us start from x square plus 2x minus 3 equal to 5. I shift 5 this side, so we derive the answer is x square plus 2x minus 8 is equal to 0. We know that minus 8 have the only one option, that is 4 2s are 8. That's why here we have to take the x plus 4, x minus 2 is equal to 0. Why? Because middle term is plus 2, 4 plus 2 and 4 minus 2. These are the options. So obviously 4 minus 2 gives plus 2 there. So we derive x equal to minus 4 or x equal to 2. In this example, most probably we have to use log m plus log n. Then we have to compulsory convert the logarithmic form, that is log to the base a of y is equal to x in a form of exponential a raised to x equal to y. That's why 5 raised to 1 is derived. That is the important step in this example. Then we have to take the factorization method of the quadratic equation, middle substitution. Then we derive the final answer in a form of x. Let us start from the new example for 4 marks in a MSBT board paper. Log 2 to the base 3 plus 2 log x to the base 3 is equal to log 7x minus 3 to the base 3. We observe that each and every term base is same, so we can easily applicable the laws of logarithm using plus or minus is there. So let us start from the plus. Why? Because log 2 to the base 3 plus log x to the base 3 and 2 is in a multiple. Here base is same and 7x minus 3 the factor is given. We know that log 2 to the base 3 remain as the same, but n log of m is log m raised to n. That's why these two convert to the index of the given variable, and these remain as the same. We know that log m plus log n is log m into m. That's why log 2x square, because 2 into x square, 2x square, and base remain as the same. Here log 3 to the base and 7x minus 3 is the term. We know that log m is equal to log n, log get cancelled, m is equal to n. That's why log to the base 3 get cancelled, log to the base 3 is get cancelled, middle is equal. So we remain only these terms. 2x square is equal to 7x minus 3. We simplify obviously. 2x square minus 7x plus 3 equal to 0. Here the two 3's are obviously 6. We have to take the multiplication, that is the middle substitution for this. So obviously 2x minus 1 and x minus 1 are the factors of this quadratic equation. Last lecture we studied about the how to find the quadratic equation by middle substitution method, or minus b under root b square minus 4ac upon 2a. Now we derive 2x minus 1 equal to 0 or x minus 3 equal to 0. Therefore 2x equal to 1, that derive x equal to 1 upon 2. Here x minus 3 equal to 0, that's mean x equal to 3. So we have the both values of x equal to 1 upon 2 and x equal to 3 in the given example. Here in this step we have to equate by using the main laws of logarithm of power function, that 2 goes to index, that is n log of m is equal to log m raised to n. In these two terms middle plus is there, so log m plus log n is log m into n. Then we use the important laws of logarithm, that log m is equal to log n, the log get cancelled, we derive m is equal to n. That's why log 3 get cancelled. We derive the quadratic equation, have the coefficient 2, simplify by middle substitution, and we derive the both values of x 1 upon 2 and x equal to 3. Let us try from the next concept. That is what? A raised to log to the base a of f of x. These all get cancelled and we derive only f of x. E raised to log to the base e of f of x is equal to f of x. In this format, most important thing is that if 3 log to the base 3 of x square is there, so these term get cancelled, only x square is there. In this term, suppose e log to the base e of 2x plus 1 is there. So these all get cancelled and we remain as a 2x. Always remind that this is the base and log term must be the index, but log term have the base compulsory same number. Here also same trick apply, e log to the base e, same format is there and we derive the f of x. Let us start from the example based on the all laws of logarithm and these properties of laws of logarithm. Here solve the logarithmic equation. In a question they given 3 log of x to the base 3. So we have is equal to 12. It is best way 3 log to the base 3 is equal to x equal to 12. So how we convert these, because only one side they given, that is the main thing. So here what is 3 is in a multiplication, it divided this side, so we derive the 4. Then we have the trick, we apply how not easily 3 raised to 4 is equal to x and we derive the combination, that is the 3 raised to 4 obviously 81. So we can convert these in a form of such thing. We derive we take the base is 3 here. Be careful about this step. I repeat again, log x to the base 3 is there is equal to 4. That's why we need the suppose base is same. So we derive the direct answer. That's why 3 log x to the base 3 is there is equal to 3 raised to 4. Just we derive that a raised to log of a of f of x is equal to f of x. The whole these term get cancelled. We derive answer is x. And 3 raised to 4 is obviously 81. So we derive the final answer from this step also and using these properties of logarithm. If you don't rebind all these property, in this example, we directly solve logarithmic function into exponential. We derive the this side, this goes to 3 raised to 4 is equal to x, and obviously final answer is 3 raised to 4 is equal to 81. If you have to not substitute these step. Both way you have to solve, that gives the right marks to that example. Now, let us start from next example. Solve logarithmic equation ln. Obviously the base is what? The obviously base is e only. So finding e the power of each side allows to set the values and parentheses equal to each other. Means what? If log of m is equal to log of n, that means log m is equal to n. Ln is also possible. Ln of m is equal to ln of n is equal to m is equal to n. 4x minus 7 is equal to x plus 5. That's why we have to equate 4x minus x, or minus 7 remain as the same, 5 is there. We simplify 3x equal to 12, x equal to 4. Second example, we have to must remind that before goes to second example, we have to must remind that if ln is given, does not matter about which base is given, we have to consider e is the only base. So that's why ln of m is equal to ln of n is equal to m is equal to n. That's why ln get cancelled. We derive the only terms there. Be careful about this step. Second example, we observe that log 5x minus 17 to the base 2 is equal to 3. What do we take? We take the 2 is the base. So we have to take the base of 2 to both sides. So it is more important that 2 raised to log to the base 2, 5x minus 17 is equal to 2 cube. Because we take base is 2, so we have to know that a raised to log to the base a of f of x equal to f of x. That's why here base is important. That's why these all 2 log 2 to the base 2 get cancelled and we derive only 5x minus 17 is equal to 8. Why? Because 2 cube is equal to 8. Now 5x 17 gets this side, so it is 5x plus 25. We easily divide the x equal to 25 upon 5. In this example, more important step is that we have to easily solve the 2 raised to 3 is equal to 5x minus 17 using logarithm convert into exponential form also. And we derive the same answer in this example. Now let us start from the next example. Log x to the base 9 is there and plus log x minus 8 to the base 9 is there is equal to 1. We know that base is same and plus is there. So we know that log m plus log n is log m into n. That's why base remain as the same, x into x minus 8 is equal to 1. Again in this example, we have to take the 9 is base for the logarithm. So 9 and here also 9 raised to 1. We have know that a raised to log a of f of x is remain f of x. That's why these f of x remain as the same and 9 remain as the same. Simplify, we derive x bracket multiplication x square minus 8x minus 9 equal to 0. We know that in a quadratic equation form, always 9 ones are 9. So we need minus 9 plus 1, only one option is there. So we distribute x minus 9 and x plus 1 equal to 0. That's why x equal to 9 and x equal to minus 1. But x equal to minus 1 is not possible in a logarithmic function. That's why only x equal to 9 is the final answer. I explain this example again. Log x to the base 9 is there and log x minus 8 is 9 is there. So we use the main basic concept log m plus log n is log m into n. In this step, we important use that we take the 9 is base to both sides and index goes to this term. And we simplify the quadratic equation and we derive the final values of x by middle substitution of 8x minus